Honored to be a part of the webinar series offered by Pimpri Chinchwad University. I'll start with my brief introduction. So I'm Sumit Jagdale. I'm from Pune, and it's been last 10 years I was working in Taiwan. It's been like 7, 8 months. I just came back to India. So I'm also director and CEO of another company, Evalyn Healthcare Solutions. That's my own startup. And I'm also heading a position as a technical head at Solomon Technology Corporation, the company based out of Taiwan. And I'm heading a team in the USA and Taiwan. And pretty much I'm taking care of all these international deployments. I'm taking care of all these applications for the robotics, path planning, and computer vision applications. And pretty much uh, I've been working in this domain for last 10 years. So we have deployed several applications in India as well. So I would love to showcase some of those applications and pretty much AI, computer vision, machine learning, deep learning, robotics are my research core interest. And I'll be also talking about some my other developments in health tech. Okay, so just to start with this big circle, I know this AI is a very vast and often, overused term in today's tech discussions. And while everyone is talking about AI, so real impact comes basically when we have these technologies applied for the real-time applications there. So in this talk, we will just narrow it down. So I'll be talking more about robotic applications that goes with, let's say, computer vision developments along with deep learning and machine learning techniques we have used, the tools we have developed for these applications there. And again, of course, using deep learning and machine learning techniques, we will explore how these machines are getting the ability to see, interpret, and make the decisions while performing some actions in real-time applications there. So the way I started, so about my journey, so after completing my bachelor's, so I decided to pursue my master's in robotics. And back in 2013 and 14, we had very limited institutes and organizations offering, let's say, robotics and AI courses. So where I had decided to pursue my master's abroad, and this is where I landed in Taiwan, and I got an opportunity to work on autonomous car. So I did my master's research and thesis at this Industrial Technology Research Institute. This is one of the prestigious research organizations from Asia, and that is among top 100 global innovators organizations. And this is where I started working on autonomous car, and I got into computer vision domain. So if you look at this particular slide, so I was responsible for this stereo vision and lidar camera calibration. So this is where I developed some of the algorithms for integrating these two sensors, which is a key or critical sensors being used for autonomous vehicle there. And I was responsible for developing an algorithm to integrate these two sensors with respect to calibration parameters. And for a brief understanding, this Velodyne lidar that generates just laser point cloud. So that is just giving you 3D depth information, but just to have real-time mapping with the actual 3D reconstructed environment, we have a requirement of putting this environments to the RGB values, right? The color point cloud in layman way. So this is where I integrated these algorithms and integrated these two cameras together. And if you look at the right side, this is where you can see using the algorithms, we were able to actually 3D reconstruct this environment, outdoor environments, and we were able to use that for mapping for the Google Maps and all. Okay, so I'll be talking about after that. Then I got into industrial robotic applications at Solomon, right? And this is the company where I was taking care of all those projects from Taiwan, and now I'm operating from India. And I was heading this department at Vision Business Unit. Okay, so pretty much globally, within last 10 years, I mean, these are very few customers I've mentioned here. So globally, we have deployed our applications at all those multinational companies. And in India also, to name few, we have worked with Tata, Siemens, John Deere, Seiko Tools, Bosch, and currently I'm dealing with one more projects like Applied Materials. Okay, so basically, as we know that this AI, it's a vast term, right? So just to narrow it down, I will be talking about specific applications we have built. So by leveraging one AI engine with respect to deep learning tools, machine learning tools, and on top of which we have developed these applications. So accordingly, we have this kind of products we have developed, and which goes with, let's say, AcuPick, that is a robotic application. I'll show you a few of the videos there just to get you an understanding of how this basically how this application works in real industrial applications there. Okay, and for all these developments, we have bagged several awards and recognitions globally. And the Red Dot Design Award is one of the prestigious awards in this domain, and we have bagged some awards in the USA as well for these developments. So just to talk about this ecosystem, so basically we are not just offering a product. Basically, we are offering an ecosystem. So this is the pain point for, if you can look at if you look around, many companies, every company is like they want to integrate something with AI, and it's a need basically. So what happens when it goes with implementing or integrating some existing solutions? So this is where they have limitations of the infrastructure, of the sensor integration, and specifically talking about industrial applications where people want to integrate their applications with the robotic solutions, right? This is where they have limitations with respect to sensor selection, the communication protocols, then the complexity of using these AI tools, deep learning techniques, and all, right? So this is where, taking under consideration all those pain points, we have developed an ecosystem. Using our software platform, we are supporting more than 25 different brands of industrial robots, including cobots. And using the same platform, we are supporting more than 15 different vision sensors, that's in 2D and 3D. So as per the application requirement, end user can select and choose the appropriate sensor, and they can work on the applications there. And most importantly, the communication protocols. So sometimes they want to integrate robotic applications into their existing process flow, right? So this is where, without affecting the current flow, they want to communicate the external devices or the sensors by means of robot or vision system. This is where the PLC communication plays a very big role. So this is something we are also offering with respect to Modbus communication and the PLC communication. So this is the entire ecosystem we have developed. And at the center, you can see the AI engine. So basically, we have developed all those AI tools, complex AI tools, in a very, how to say that, like it's using a no coding platform. We have put them into a very simple user interface, so people can simply just connect the camera, uh, let's say, capture some images, annotate them, and within like few minutes, they can just train the models and they can deploy it. And this is how the entire software stack works. So now we are talking about, let's say, computer vision and deep learning applications, right? At the foundation, we have these building blocks where we have integrated those AI tools. We have integrated drivers, SDKs for 2D camera, 3D camera. Then we have integrated these motion planning algorithms, right? Then we have these vision systems with respect to 2D and 3D, and we have configured multiple industrial PCs supported by different types of GPUs. So as per the application requirement, as per the computing power requirement, they can make use of specific industrial PC there, right? And as we discussed about the PLC communication. So all these blocks are being used to develop any particular applications in automation domain there. So just to start with this one, so just look at this white camera. So it's a structure-led scanner, and that can generate a very precise point cloud. Okay, and if you look at the left side, so this is where you can see this is a no coding platform. It's based on let's say uh, the blocks, and you can simply connect those blocks to each other by connecting those links. And as per your logical process flow, as per your required process flow, you can simply connect those blocks to each other, and accordingly, it will just define the process flow. Each block has its own settings. So we can define, let's say, camera settings, robot settings, TCP settings, communication settings. You can put the variables. So this is what is happening, because when it comes to industrial application, right? So let's say today engineer is, let's say, good with, let's say, Fanuc programming, right? And tomorrow he wants to go ahead with, let's say, universal robot, or he wants to go with Yaskawa robot, right? So they have to keep learning all those different programming languages there. But this is where platform like this is really helpful, because simply dragging and dropping those blocks, you can automatically set up those parameters, we set up those waypoints, we can access all the IO controls, communication through this software platform. And without writing the program at the controller uh, panel, you can simply generate the script automatically by using this software platform. So this is how we have been, building all those applications. So the reason I'm showing all those things, for students basically, because when they look at the robots, right? So I don't know, many people think of, when it comes to robot, they think of, let's say, humanoids first of all, but there are a lot is happening with respect to the robotic arms. The drones are there, then we have some other different kinds of robots are there. So the robotics field itself is a very vast field. So when they are looking for developing something, or let's say trying to master any domain, so they should first of all focus what exactly their interest is, what is the requirement in industry, right? So accordingly they can, dig down the requirements, and accordingly they can try to explore the opportunities there. So in this left image you can see the key element here is the calibration. So when it comes to industrial application, every single company asks you, hey, can you do this in, let's say, 4 seconds? Pick and place accuracy is has to be within, let's say, less than 0.5 mm. So this is where these algorithms you're developing with respect to vision camera or vision to robot calibration, right? So basically we are just calibrating these robot coordinates with respect to camera coordinates, and this is how, based on this calibration, we are able to give eyes to the robot, basically robotic arm, right, in a layman way. And importantly, what happens when it comes to industrial application, sometimes their environment is pretty much limited. So this is where we have to take care that robot is not colliding with the beam borders, robot is not having any collisions, or robot is not getting into deadlock position due to joint limits and all. So this is where this motion planning algorithms plays a very big role, and that has to be taken care very well. So recently, I would like to mention, so in collaboration with NVIDIA, we have launched our new solution in humanoid domain. And we just launched it like 4 or 5 days back during this Computex event in Taiwan. So I would like to play one small video there. But unfortunately, I don't know if you can hear the audio. Hi, I'm Kyle, and this is Solomon, an innovative humanoid robot. Can anyone confirm with me if you can hear the audio there?
Yes, sir, we are able to hear the audio.
Okay, that's good. Thank you.
Yeah.
Today at Solomon Technology. Solomon is equipped with 3D and AI vision running on NVIDIA Jetson. Today, Solomon's going to demonstrate a few tasks, but first, let's test its vision at a distance of 16.5 feet. Hey Solomon, what's the second letter from the left on the last row of the eye chart in front of you?
The second letter from the left on the last row is E.
Correct. Okay, vision is good. Now, let's put Solomon to work. Solomon is a dream for facility managers. For example, we trained Solomon's AI to accurately read and determine the value of these meters at a distance of 10 feet. So, let's see how Solomon does. Hey Solomon, what's the readings on the meters in front of you?
The reading on the left gauge is 28, and the reading on the right gauge is 90.
Perfect. Okay, now let's see if Solomon can do something a little more difficult. Solomon is also a manufacturer's dream when it comes to quality control and defect detection. For example, using only 7 images, we trained Solomon to count, classify, and identify any defects on these coffee pods from a distance of 10 feet. So, let's put Solomon to the test. Hey Solomon, count and classify the coffee pods in front of you. How many of each flavor are there? How many total? And do you see any defects on the capsules from where you're standing?
There are 4 Choco, 5 Voluto, 3 Corto, and 5 Venetia pods. Total 17 pods. Dents found on Voluto, Venetia, and Corto capsules.
Perfect. Okay, now let's see what Solomon can really. Each of these contact lens boxes contains a unique prescription and a unique QR code. However, only this box contains the prescription that we're looking for. First, I'll ask Solomon to locate the correct prescription, but you'll notice we've covered the text on each of the boxes so that it locates it using only the QR code. Let's see how it does. Hey Solomon, locate contact lenses with prescription -2.5 diopters by scanning the QR codes of the boxes on the screen. Just to highlight one more thing, all these commands are given through this generative AI tool. Okay, so we are just giving all those audio commands, and this is how the body is taking those commands, accepting those, and accordingly taking the actions. And if you can see, this all has been happening on, let's say, just an Orion, the NVIDIA hardware, and everything is getting processed within fraction of a second. Sure.
The contact lenses with a prescription of -2.5 diopters are located at position 1453, 266, 9998.
Okay, but I don't know what those coordinates mean. So, hey Solomon, walk to the shelf and pick up the item you just located.
Item pickup in progress.
So this is sort of like pick and place application, right? So the body is like going and as per the coordinates it has captured around this from the distance of 10 feet, right? And it is precisely able to pick this object there. So this is where the 3D camera depth sensor plays a role. So basically this is just a humanoid, but we have integrated this humanoid with multiple sensors there. Okay, so we are really proud about this collaboration with NVIDIA because NVIDIA is evolving a wonderful ecosystem with a lot of libraries, a lot of wonderful hardwares they're building, and they're making it more and more compact so that we can easily mount on or mount all those hardwares easily onto mobile applications there. And this is something Jensen Hang recently presented one of our solutions called for Acupic. So we have leveraged their Isaac libraries, Omniverse libraries to train our robots for motion planning. So you can see the complex task here. I'll just run this video. So basically, this is the camera. So at the top, you can see it's a Microsoft Kinect camera. And that is like scanning these objects from beam. And both the robots are getting the coordinates and they're picking these components in real time by using a real-time motion planning without colliding with each other. At the same time, if you look at the bean, the green one, it's industrial bean, right? And it's having a quite a big depth there. So robots are not colliding with the bean borders also. And also robots, when they're picking these objects from one bean to another, they never get into the deadlock mode or they never get any joint limits also. This is how these motion planning algorithms plays a very big role there. And all this motion planning in real time happens just within a fraction of a second. So it takes hardly like 300 milliseconds to plan the motion, and we get those coordinates to the bot controller within like next 50 milliseconds. And this is how at the back end, the robot script is getting generated and robot is performing the actions. Okay. Again, at the software architecture, so this is where we are putting all those things. Let's say combined with the Docker container, right? And we have developed all these algorithms on, let's say, ROS platform. And as I already mentioned, we are leveraging this NVIDIA hardwares and libraries from there. And we have built web interface so easily they can just deploy the applications by setting few commands or by conducting the calibration there. Again, recently NVIDIA has launched one more important function and the feature called unified 6 degree of pose estimation. That is for the tracking using the foundation pose. And we have deployed these libraries, these deep learning models within our existing solutions. Just to give you an example, let's say in industrial application, sometimes you do not have enough time to train your calibrations and all, right? So simply by using a foundation pose, using a single pose with respect to the CAD model, you can easily teach the components. So let's say if you're dealing with too many different SKUs, so that process becomes very easy for you. By just following few steps, you are easily able to train your robot to follow some specific path. So for example, in this application, let's say it's doing scanning with 2D camera, and then it is giving you the inspection reports, right? So what happens, let's say, for example, if the position of this, let's say, hardware gets changed, right? So this is where using foundation pose, the robot will automatically sustain and adapt its positions and the coordinates accordingly. So it will just try to maintain the same coordinates we have taught during the training. So this is how this 6 degree foundation pose estimation and tracking works. So coming up on next, we have done similar applications using 3D camera as well, right? So when it comes to 3D camera, so you can see it's the engine part, right? So simply by using a real sense, so in previous application, you have seen Microsoft Kinect, right? And now we are doing this application using Intel RealSense. So it's pretty cheap camera, comes only for $200. But if you can look at this particular application, now this person is like moving the component in real time. And just with one scan, a robot is able to adapt to its already trained coordinates. So we have deployed this kind of applications at automotive industries there. Okay. coming up on next, what happens like when it comes to transparent objects. So again, even though we have so much advanced deep learning models, we have advanced revision sensors, we have laser sensors, structured scanners, right? But sometimes there are limitations with respect to transparent objects. So when it comes to automotive applications where you have to, let's say, scan transparent object, let's say application like gluing, right? So we have built that application using Araku code.
Solomon's latest automation solution.
So before I run this video, I would like to highlight one more thing. So when I say we are building an ecosystem, right? So in this particular video, you can see this entire system is equipped with, let's say, AGV. So that's MIR AGV we are using. Then we are integrating a universal robot on top of it. And again, that robot is integrated with the camera, right? So basically, we are controlling three hardwares using a single software platform, right? And on top of this, we have given a vision application by simply using one Araku code. So if we can look at this Araku code somewhere here, so without doing any sort of like additional training and all, just looking at the Araku code that gives you a transformation matrix that can easily, help robot to guide its motion path.
Introducing AccuPick LM, Solomon's latest automation solution. Developed by Solomon's expert engineers and certified by Universal Robots.
Scanning the Araku code.
With a built-in barcode scanning function, AccuPick LM offers greater versatility. Coupled with AGV or AMR applications, the robot arm can be deployed and accurately positioned using markers. Rapid and accurate positioning without the need for jigs, fixtures, or clamps, making automated production lines simple and easier to maintain.
So these are basically gluing applications.
Orientation is different each time. AccuPick LM can still accurately locate the target using markers.
That's the real-time position change.
Install AccuPick LM through UR apps and operate with ease directly on the UR Teach Pendulum touchscreen.
Okay. And now we'll just look at this one more application, how it works with the vision system using, let's say, 3D structural scanner. So I implemented this project at Toyota Taiwan and then Mazda USA. Okay. So it's a really interesting application. Let me just explain to you before I run this video. So what happens when the car is getting lifted up from the previous station? So again, you can look at these pictures. They are not so accurate. So the car is always having some sort of deviations. Let's say this is a car, right? So car is always having some deviation. So if you look at the length of the car, if the deviation is, let's say, in few degrees or centimeters, right? So over the length of the car, that becomes too big. So what happens if we look at this bottom side? So we have several robots placed at the bottom of this car, right? And these are equipped with these gluing tools. So what happens when the car is having shift? All those robots are taught with, let's say, more than 600 or 700 waypoints. And if this car is, let's say, moved from its fixed position, then all the robots are not going to follow all the waypoints accurately. So this is where vision plays a role. So I'll just run this video. So you will see one camera is flashing a light. So we are just scanning a very small portion of the car. Okay. And based on that small 3D point cloud, we are able to detect the segment. We can segment this 2D image. At the same time, we are using the golden model. And using this small portion of 3D point cloud, we are able to calculate the car's deviation with respect to that fixed position. And within fraction of seconds, we are giving those deviated coordinates to all four robots. So just observe the process. So now it will just scan. So it has scanned this part, right? And then it will compare its position, this new position with respect to the golden model. And then all those deviated coordinates have been given to all four robots. And then all four robots get activated, and then they will start doing these gluing applications in real time. So the robots will never have any deviations while doing this gluing. So what I'm trying to show here, these are this is how we are combining this AI tools. We are combining these applications from the 3D and 2D vision sensors. So I have chosen very few applications, right? Because of the time constraint, but you can look at this. It's a wide application domain, right? Just looking at, let's say, a single setup, let's say one robot, one 3D camera, we can do n number of applications there. So when it comes to motion planning, as I mentioned earlier, right? So again, that's a Intel RealSense camera. And when it comes to industrial applications, we have to achieve this path planning without having any collisions there. So you can look at this video. I'll just make it, let's fast forward it. So you can look at this complex, picking. So look at this particular picking orientations, right? These are very much complex. So in general programming, what happens, these robots always get into a deadlock position, or robot may not be able to get that inverse kinematics. It cannot plan the motion without having collision, or when robot has a collision, it will just stop right there, right? And this is where we have developed advanced algorithms. So we always make robot to reach out maximum possible positions without getting into joint limits, and of course without having any collision with respect to the surrounding environment. And we process that entire algorithm within, let's say, 200 to 300 milliseconds. So that is very quick. And most importantly, as many people must be aware of this RealSense camera, it does not offer a really high quality point cloud, but still using our AI tools, we are able to achieve or compensate that accuracy within our deep learning algorithms. This is another application we have deployed at Siemens India, right? And the complexity of this project was recognition patterns. So if you look at this bean, it has more than 1,700 components placed at the same time, and robot needs to pick all those components and place them into a certain orientation. So this is where they were struggling to figure out the vision system which can give them the correct coordinates within, let's say, 1 millimeter accuracy. And of course, they have to get all those components with respect to patterns. They wanted to get it recognized. So this is how we did this application, right? So again, we have just pick application. So this is something we have deployed at FedEx, Germany. And just take a look at this video. It's really interesting. So in this particular station, we have deployed, let's say, multiple cameras. So the camera sitting on the top. So the robot is picking from this area, right? So this area is nothing but the 3D picking zone, where we have placed one Microsoft Kinect camera that is scanning those 3D, scanning those components or SKUs in 3D. And importantly, what happens when it comes to logistic applications, right? So in logistic application, we do not have fixed SKUs. They have like thousands and 2,000, 3,000 SKU, different types of SKUs. So there is no way you can keep training the model for single SKU there, right? So this is where we have built advanced deep learning tools and the segmentation algorithms, where whatever the object you will see, I mean, when the camera sees the object there, right? So we'll just segment that in 2D and 3D, and based on the depth information, based on the size, we are just like segmenting that out, and we are giving those coordinates to the robot system there. Let me just run that again. So that is like double pick. So the 2D camera will inspect that, and we will command robot to take it back to the picking zone again. And then again, it will try to pick one more time. And at the end, you can see there is a flipper, right? So that flipper is made for inspecting if the barcode is present or not. So based on this barcode recognition, if the barcode is not there on the top surface, it will just try to flip that component, because components or the objects or the SKUs with barcode are only accepted within that process flow. So again, we are offering all those integrations within a single software platform without without having any requirement of like coding and all. So we try to make it as simple as possible for system integrators there. And this is really interesting fact. When we started back in 2015 and 16, we had like a limited computing power. I used to train the models for even like, I don't know, many of you have faced this. I used to train the models for 3 hours, 4 hours, maybe by, scanning, or let's say I used to have, let's say 10, 15 images with, let's say 150 annotations and all. And we used to train that model for 3 to 4 hours. And please take a look at this particular video. And I know today's era, we are able to train this model just within a few minutes now. So take a look at this timeline at the top. So we do have simple components there, and we have 3 different classes. So we are just creating a classes, and we just need to annotate a single image. So based on a single image, we are able to train the models nowadays. And these kind of advanced deep learning tools we are developing now. So that is really important, because that saves a lot of time on building the models, training the models, and importantly, the manual annotations. So it's done. So model is trained and it's ready to deploy. So you can see the real-time detection as well. And once your body is ready, then you can just start picking and sorting them out. Again, coming up on next, we have deployed new applications, and that is called Meta IV. So we have developed a new architecture. So looking at the current scenarios and the application requirements in multiple automotive industries, automation industries, where we have given them a platform now. So now we are deploying this deep learning, machine learning models onto the server, and we are offering real-time inferencing to be done on, let's say, AR glasses, IP cameras, or let's say using your tablet or mobile phone camera. So we are giving you even more flexibility. And this is where this architecture plays a very big role. So I will just run one small video just for your understanding.
Ivy is a portable AI vision system that combines the power of machine vision with human dexterity. Quickly deploy in a few simple steps. Easy to operate and fast to deploy, Meta Ivy leverages instant learning technology capable of building an AI model in seconds rather than days for maximum efficiency.
So that's the real-time inferencing.
Solomon's AI-powered AR platform integrates seamlessly with regular smart devices, including AR glasses, smartphones, tablets, body cameras, and IP cameras. Smart factory management. Meta Ivy eliminates time-consuming error-prone manual meter reading processes. Empower operators in the field with instant precise gauge meter reading. Automatically populate forms for greater inspection accuracy and efficiency. SOP validation. With AR guidance and AI verification, Meta Ivy ensures personnel follow SOPs and keeps performance records for compliance. Reinforce correct conduct and accelerate new staff training. AI surveillance. Easily connect to our server within the network domain to leverage existing surveillance cameras for upgraded AI recognition. Meta Ivy's intelligent remote monitoring capability enhances the safety and security of personnel, equipment, and facilities. Worker verification. Cross-check inventory and orders with AR glasses for hands-free operation and calculate quantities with precision through AI. Maintain accurate inventory and order history whilst reducing human error. Deployable through different platforms and scenarios.
So we have really very good demand for this kind of applications because this is really giving more flexibility when it comes to deployment, because we are just putting all those models trained on the server, and then you can connect, let's say, 5 to 6 devices to the same server. So we have different specs given for all the servers and the model training pieces there, right? And you can easily connect this smartphones, tablet, IP cameras, AR glasses. So pretty much, like using existing hardware, even body cams. Even we have deployed some applications using the drones. So we are leveraging the drone cameras, and then we are communicating that for real-time inferencing using the server communication with respect to drone as well. So this is really interesting to see, how this technology is getting adapted. And again, the reason I'm not promoting any products here. So the reason I'm showing you all these different applications, just to let you understand, by keeping this AI engine at the base, what are the applications we can build, right? And if you look at this application domain when it comes to robotics, computer vision, image processing, machine learning, there is a lot can be done. So my suggestion for the students would be, without getting confused, whether you try to streamline your interest, first of all, whether you want to work when it comes to robotics, right? So you better you figure it out where you want to work for humanoids, you want to work for industrial arms, or you want to work on, let's say, drones, or if you want to work on some other applications. So first of all, you have to figure out that one, and accordingly you can get into then the deep learning, then the machine learning, and computer vision applications comes into the picture. So this is something you guys need to really look forward, when you are looking at those application development. So when you consider those things for, let's say, your mini projects, final year projects, or the research topics, right? So this is how you should look at all those developments happening around the world, the industry. You should try to understand the industry requirement as well, like what is happening there. We are talking about industry 4.0, 5.0, but what is exactly needed? And when you be there, or when you look at yourself as application developer, right? So these are the things really matters a lot. Otherwise, everybody's talking about AI, right? But it's not like we can design and develop everything. So we have to really need to be focused when you are going to choose your applications there. Okay, this is like the last application I have with respect to 2D cameras. Okay, and I hope my screen is still visible, right? Could you please confirm?
Yes, sir, it is visible.
Okay, great. Yeah. So this is something using 2D camera. So if you know, Taiwan is a hub for semiconductor manufacturing and PCB manufacturing industries, right? So this is where you can look at this particular case where just a single 2D camera is looking at all those n number of components being placed on this PCB board, right? And just by indicating that with respect to green or red light, so you can look at this inspection. So he just removed one component from the existing PCB, and then he was getting that red color there. And again, that processing is happening just within a fraction of a second. Just imagine person is just looking at this PCB and just trying to remember all the component positions and the specs. It's way more difficult, and it's very much time consuming for them, right? Okay, so enough about robotics. I would like to talk about one more domain about my startup. So just to get you an idea, like how this AI is also playing a big role in health tech domain as well. And so we have developed a wonderful device called IX, Intelligent Analyzer Express, and we have it approved by US FDA, CDSCO. Then we have it approved by Taiwan, Brazil FDA. So pretty much we are ready with all the compliances. And just to give you a glance, I'm just running a small AV there, just to let you understand about the technology.
Meet the IAX Intelligent Analyzer Express. It's the only universal rapid test reader. The IAX is built to be the ultimate analyzer for efficient diagnostic mass testing. It has precise test reading capabilities. The invention of the IAX in combination with Open Bio database and the Open Bio API combines the technology back-end and front-end to be able to do mass testing on a grand scale. It uses universal lateral flow assays from any vendor around the world and can be quickly deployed. At the hardware level, the IAX integrates a camera and a multi-color LED with diffusers and computes analytics using a powerful embedded computing board with an Intel Core CPU and Intel Iris Xe GPU to process massive text data in real time to assure accuracy beyond the capabilities of human eyes. We use the most accurate and efficient method to help reduce the burden on the medical professionals and assist the government to reduce the spread of infectious and vector-borne diseases like influenza, COVID-19, HIV, hepatitis, dengue, malaria, chikungunya, leishmania, or Kala Azar, and more. Patients can easily create Aadhaar card on Evalyn DX EHR system. After registration, when the patient sample is collected, our secure process ensures complete anonymity. Reports are generated and delivered within a minute, ensuring a smooth end-to-end experience. Number 1. Use the scanner to scan the barcode or the Aadhaar card to obtain the patient's unique ID. Number 2. Apply the barcode label to the test cassette. Number 3. Collect the sample for rapid test. Developed test delivers results in about 15 minutes. Number 4. Insert the test cassette into the reader and accurately displays the qualitative as well quantitative results in seconds. One can also get the results through the API using third-party mobile apps or through the secure web portals. Evalyn Healthcare has developed a highly scalable cloud platform in collaboration with AWS services integrated with LIMS and NHA's ABDM platform. This enables secure export and sharing of diagnostic test reports linked to the patient's Aadhaar card. The device and the solution fit perfectly within the guidelines offered by World Health Organization in conjunction with FIND for the functional requirements of lateral flow machine readers. Empowering India, empowering life.
So, intentionally, I'm showing you this health tech domain as well because I just want to let you understand, leveraging AI basically, now we are deploying these particular devices for, let's say, primary healthcare centers. We are deploying these devices to help and support low resource setting areas like tribal and rural locations where the facilities are quite limited. So we are putting those advanced technologies there where, even ASHA workers, you can look at this video. So ASHA workers can reach out to the family, they can get people screened, and within fraction of second, they can, get all those diagnostic reports reported to not only to the district or state level, but in real time, we are able to offer the services where they can get those reports reported to the National Health Authorities platform. And just imagine the test you're conducting at the tribal location is getting reported to the NHS platform called ABDM, right? And that's the beauty of, AI. And the reason I'm showing you this one, because AI does not mean, or application does not mean we have to solve only the high level problems, but using the AI, we can solve all these problems at the ground level as well. And this is where I have deployed solutions at a very high level in MNCs in the USA, Europe, in India as well at particular MNCs. But at the same time, using the same technology of my same foundation and the experience of computer vision, machine learning, now we are deploying applications in tribal and rural locations as well. So ultimately, it's all about how you look at the problem, how you look at the technology, and how you do combine all those expertise to bring a useful solution for society, right? So that's all about my presentations, and I'm really glad that we have now universities like Pimpri Chinchwad University, which is offering AI platforms and robotics platform. And these are my contact details, and I would love to get in touch with those people who have any questions, queries, I would like to discuss with me. And I would love to contribute for designing any training programs with this university. So I'm always open for all this opportunities and networking. Thanks a lot.
Thanks a lot, sir. Thank you very much for a wonderful presentation. We have thoroughly enjoyed it. All of our audience have thoroughly enjoyed the presentation, and especially the videos and the with the help of videos, the way you have illustrated the subject is very nice to us.
Thank you.
So some of the questions I have got from at my end. So may I ask that, sir?
Please go ahead.
Yeah, one of the questions which I've got is what are other sectors, sir, where this robotics technology can be deployed, and is it economically viable?
Yeah. So very good question. So this is how, when I came back to India, when we are looking at those small scale industries also, right? So when it comes to the application requirement, for example, I talked about different camera sensors, right? So if you just compare two camera sensor, let's say structural light scanner or the laser scanner, right? So those scanners are quite expensive. Those comes for, let's say, several $100,000 sometimes. Okay, but at the same time, this Intel RealSense or Kinect camera just comes for $200 or $300. So that's relatively, cheaper. And importantly, there are a number of robot companies are coming up with, let's say, good features and with affordable prices. Like TM Robot is there. There are certain other robot manufacturers. They are bringing cobots at very affordable prices. So it's all about the combination of these, sensors and the robot. So again, if you are not expecting a very high resolution cameras or not expecting any high accuracy application, so definitely we can always go for those kind of lower resources which are relatively cheaper and can be able to achieve your application. And at the end, it all about how the AI is supporting, to work with those lower resource settings also.
Okay, sir, that explains everything. Thanks a lot for your presentation. And most importantly, thank you for taking out your valuable time to educate all of our audience, sir. So,
My pleasure.